This next example is very similar to the previous one, the only difference being that in this particular example we have some square roots appearing, so we need to be a little bit more careful. So let's run through this. First term, a, is 1. The common ratio, well, what's that going to be? Again, I can do subsequent term division, so root 3 on 1, that's the square root of 3. You could also do it by going 3 divided by root 3. Okay, oh, that is an awful square root sign. 3 divided by root 3. Well, that thing there, it's a little harder to see how this cancels. Maybe fractional indices would be a better way of doing this. That's 3 to the half. So power here is 1, the power there is a half. Subtract the indices, I get 3 to the half. 1 minus a half is a half. That's the square root of 3, which is the same thing. Okay, so that's what our common ratio is. I'm asked to find the sum to 8 terms. So the sum to 8 terms is, using my sum of a geometric sequence, or geometric series rather, formula is a times r to the n minus 1 on r minus 1. That's 1 outside there. My r is the square root of 3. My power is 8. And on the bottom I'm going to have square root of 3 minus 1. Okay, so this one's going to need a little bit of tidying up to be a bit nicer. Let's use our index laws on that top there. We take the square root of 3 and we write it as a fractional index. And divide by the square root of 3 minus 1. Tidying up here, we get 3 to the 4 minus 1. And again, 3 to the power of 4 is not the kind of thing you are expected to be able to do in your head. So it is okay to use a calculator at this point. So we will go 3 to the power of 4 and get 81 minus 1. So 81 minus 1 divided by the square root of 3 minus 1. This is 80 on the square root of 3 minus 1. Now that is not going to be a particularly nice number. We haven't spent much time doing simplification of surds in denominators. If we were going to ask this in an exam, we would expect you to get to kind of that point and then we'd be happy with that as an answer. I, however, am going to rationalize our denominator. I want to get my square root off the bottom. The trick for doing that, if you're interested, is you multiply by the negative reciprocal over itself. So in other words, this is square root of 3 minus 1. I'm going to multiply by square root of 3 plus 1 on square root of 3 plus 1. This whole fraction here is equivalent to 1 because I'm dividing one thing by itself. So I'm not changing the value here. I'm just going to change the way it looks. So multiplying along the top, I would get 80 times the square root of 3 plus 80. On the bottom, I'm going to have square root of 3 minus 1 times the square root of 3 plus 1. This is really ugly working here. Bottom here, if you expand that out, you end up with the following. You end up with 4. No, you don't. You end up with 3 minus 1, which is very nice. You can check that yourself if you want to expand it out. We're in a video here, so you can pause it and do some working. So we're dividing by 2 here, and that would let us tidy to get 40 root 3 plus 40. That is not a nice number, okay? But it's not unexpected. Okay, you do expect to have a bunch of terms with root 3's in them and a bunch of terms that don't, because remember the original sequence, every second term would have a root 3 in it. So all of the root 3 terms will sum up to give you this guy. All of the other terms, the odd terms, would sum up to give you this number. So that's kind of why we have this broken, ugly root 3 in our answer. So as I mentioned before, doing this kind of simplification isn't required of method students. We're kind of happy if you were to get to this point, and then we would give you your marks for there. Just for a bit of fun, I've done the rest of it, and it's good if you want to study maths further, and especially if you're in the specialist stream, to know that you can simplify like this as well.